In this video, let's talk about the operations on signals. There are mainly three types of operations which we can perform on signals, and we are going to combine all these three operations into a single operation called as the composite operation, and we are going to analyze the signals. The first operation which we are going to study is the time shifting operation. Let's take an example signal and perform the time shifting operation on it. Let's say we have a signal f of t and it is going from -2 to 2 and has a value of 1 between -2 to 2. So when we have to perform time shifting operation, we have a signal f of t and we will have to find the signal which exists at f of t plus or minus t naught. For example, we have f of t, we want to find f of t plus or minus t naught, where t naught is a constant. This constant tells us by how much we are shifting the f of t. We have two operators in this. The plus sign denotes that we are going to advance the f of t, and the negative sign denotes we are going to delay f of t. Alright, now let's talk about the advancing and delaying of the signal. To better understand advancing and delaying, let me take the time axis. In this time axis, let's say you have to wake up at 5 am, and you wake up at 5 am but decide to sleep for 2 more hours. Here you want to delay your sleep from 5 am to 7 am. When you are trying to delay something, it goes from left to right. Similarly, for signals, if you delay the signal, it shifts right. Now let's say you want to wake up at 5 am but you woke up at 4 am itself. So you are advancing your time of sleep by 1 hour. Similarly, for signals, if you try to advance the signal, it will shift from right to left. The signal is getting advanced if it shifts left, and if it shifts right, the signal is getting delayed. So whenever we are asked to perform the time shifting operation, a signal is going to be given for us and we have to perform either advancing or the delay of that signal. Remember that if you have a negative sign, you are delaying the signal, which means you are shifting the signal to the right. Whereas if you have a plus sign, you are advancing the signal, which means you are shifting the signal to the left. The T naught denotes how much you have to shift. Now let's take an example problem and perform the time shifting operation. And suppose I have to perform the time shifting operation f of t plus 2. So from the given problem, you can see that there is a plus sign, which means advancing. And 2 is our t naught. So we are told that you have to advance the signal f of t by 2 units. Let's perform that. When you advance the signal by 2 units, you are shifting the signal by 2 units to the left. So when you shift it to the left, the -2 will come at -4 and the 2 will come at 0. So you have a signal something like this. The blue lines denote the shifted signal. A shortcut to quickly advance a signal is you have to subtract the signal with the t naught. Here our t naught is 2, so I'm going to write 2. So when you subtract the values at which the signal is present with t naught, you will automatically get the shifted advanced signal. And please remember that when you are trying to shift a signal in time, it will have no effect in amplitude of that signal. Suppose now I want to perform f of t minus 4. So you have a negative sign, which means you are delaying the signal, which means you are shifting the signal to the right, and you have 4, which is the t naught. So you are going to shift the signal to the right by 4 units. Now when you delay this signal by 4 units, the -2th position of this signal will reach 2. What I am doing here is basically -2 plus 4. And here I am going to do 2 plus 4. This is a shortcut to do delay. So when you are trying to advance, you can use negative sign for changing the position of the signal, and you are using plus sign for delay to delay the signal or shift the signal to the right. So when you do this, -2 plus 4 is equal to -2. So this position will come here. and when you do 2 plus 4, it will go to 6. So it will be at this position. So this blue signal denotes our shifted signal. Again, there is no change in the amplitude of the signal. Now let's look at an example for time shifting of a discrete time signal. The time shifting of both CT and DT signals are the same. The only difference is that in continuous time, the time is represented as t, and in discrete time it is represented as n. For CT, we represent the time shifting as x of t plus or minus t naught, and for discrete time, we represent it as x of n plus or minus k, where k is an integer. If we have x of n plus k, we are advancing the discrete time signal by k samples. Similarly, if we have x of n minus k, we are delaying the signal by k samples. Just like CT signals, advancing DT signal is shifting it to the left, and delaying is shift to right. Let's look at an example to understand discrete time signal more clearly. Suppose we have an x of n like this. Then if we perform, let's say, x of n minus 2, what we are doing here is we are delaying the signal. Just like in CT signal, you have to move the discrete time signal by 2 units to the right. Now you have to add 2 units to each position of the discrete time signal. Add 2 here, add 2 here, add 2 here, add 2 here, add 2 here. Once you do that, you can tell minus 1 plus 2 will result in the first position. So this is 0, 1, 2, 3, 4, 5, let's say. Now the minus 1th position will come to the first position. This is the first sample which is shifted by 2 units. In the next sample 0, if we add 2 to 0, it will result in 2. And we can see the amplitude as 0, then we can mark the second position as 0. Now in the third sample, we again have an amplitude of 1, and the first position gets added with 2, so we'll get into third position. We have the third sample. Similarly, if you do for others, this is the resultant signal after time shifting of x of n minus 2. We had x of n and we shifted x of n by 2 units to the right. For signal advancing, you just have to move the signal to the left. So these are some examples of how to perform time shifting operation. I hope you understood this well. Another thing is that you cannot perform the time shifting operations on a real time signal which is currently happening, but you can perform a time shifting operation on a recorded signal. You can delay the recorded signal or you can advance the recorded signal, but you cannot perform the time shifting operation when the signal is happening in real time. And that brings us to the end of our lecture. In the next lecture, I will be talking about the time scaling operation. So thank you for joining. See you in the next video.